So current through a capacitor sample question. So a voltage has the sinusoidal, a voltage, right? This sinusoidal quantity is applied across a capacitor, right? Oh, this is actually micro. Yeah, a capacitor of 50 micro farad, right? And you have to find the current across it. So clearly we know that for something like this, the voltage will be, it won't be, let's see, it's not directly, what's the name, V is equal to, you have to find the current, right? So the current won't be directly this V on, let's say, IC, right? It won't be this directly, right? Because it's in terms of sinusoidal. The actual equation that we use is this I here, which is a sinusoidal quantity, should be equal to the capacitance, right, times the dV dt. So this is the equation that we use in this case, right? Yeah. So that will mean that the current that we are trying to find, right, is equal to, we have the capacitance already, that's 50. Yeah, that's 50 times 10 to the power minus 6. That's for the C here, right? The capacitance, right? Which is here. And then the dV dt is basically a derivative, right? So that's, we are finding the derivative of the 10 sine. Let's make this small so you can see what's happening. Okay. Okay. So 10 sine 300 t, right? dt. So this is all will give us the current, right? And it's saying that we should find the current at 5 seconds, right? 5 seconds, right? So if this was something we're doing manually, it will be something like this. So where we have 550, right, times 10 to the power minus 6, and then find the derivative of this, right? So that gives us 10 on 300, and then we get cos 300 t, right? And then we make the t, because we say I find t at 5 seconds, we put 5 in, so right, so that gives us 50 times 10 to the power minus 6 times, so this is so we'll simplify that. So let's put everything down now. Cos, right, 300 times 5, and this is what will give us the final answer, the current that we are looking for, right, which is sinusoidal, right? Okay, so as usual, you just have to know the equations that you have to use and then when to use them. Right, so here's the case that the sinusoidal current that we are looking for through a capacitor, right? So we have the equation, we found the parameters that we need, and there are times you must look at the units, very important. So you see it was in microfarad, so we have to make sure the micro shows well, right? We have to make sure the micro shows well. So let's see, so that's 50 times 10 to the power minus 6, right, times 10 times 10 on 300, right, cos 300 times 5, and remember this should be in radians because of the trig function that we have, times 5, right? So 50 times 10 to the power minus 6, this derivative, that's 10 on 300, a derivative, that should be, if it's derivative, this shouldn't be divided by, it should be actually 300. So 300 times 10, that gives us 30,000, right? This should be 30,000. Yes, it should be 30,000. We can confirm that when we do the derivative directly, right? So check that. 1, 2, 3. Okay. So if you have to compare, so let's see. If you are punching it directly, that will be 50 times 10 to the power minus 6, right? Times the derivative, right? And the function we have is 10 sine, right? 300 x, right? And then we are finding it when the time is 5 seconds, right? 5. So let's see this and then this. So yeah, we are getting the same thing. So confirm it because derivative it should be 3000. So yeah, the current that we will get from this is minus 0.0 U4 dB, that's 0.0165 amperes, because current unit is very important, amperes, right? Yeah. So we will check another example. Right. Check an example. Let's see. So this one says the current through uh the capacitor, and the capacitor has this, that's 20 microfarads, right? Microfarad is this, and the initial voltage is 0. We should find the voltage at 10, right? So basically still the same equation that we're going to use, right? So we have I sinusoidal current being equal to capacitance, and then we have the V, the T, right? And since we are asked to find the voltage, that will mean we have to make the dV dt the subject, right? So that becomes the V dt equal to sinusoidal current all over the capacitance, right? So let's see. This equals, we have the sinusoidal current as 0.2, so that's 0.2, right, cos bracket 500 t, right? And then the capacitance we have is 20 microfarad, so that's 20 times 10 to the power minus 6, right? Okay, simplifying this, so let's see, we have 0.2 on 20 times 10 to the power minus 6, so that gives us 10,000, which is basically 10 to the power 4, right? Cos 500 t, right? Let's try this one. 500. All right, so this is the dvdt. Let's pay attention to that, dvdt, right? But we need the voltage, right? So that means we have to integrate this. So that's integrating 10 to the power 4 cos 500 t. So let's see, that gives us 10 to the power 4 on 500, right? This is minus, so 10 to the power, there's no minus dash, 10 to the power 4 on 500, and this is sine 500 t plus a constant of integration, right? But then it has been set, this the dvdt, let's pay attention to the v there, right? The sinusoidal voltage, right? Yeah. And but it has been specified, we've been given the boundary condition, the initial conditions, right? So it says that I've the initial voltage is 0, so that's when time is 0, the voltage is 0. So that will mean that if you have to put the same, all this is equal to 0. So let's see. So that's 10 to the power 4 on 500, right? That gives us 20. So that's 20. It's saying that when we apply this initial condition, this, it says that 0 is equal to 20, right, sine 500 times 0, one time is 0, right? So when this t is 0, because you're applying this boundary conditions, and then this here is a t, right? The 0 here is a t plus c, right? So plus c, so that will mean that 0 is equal to 0 plus C, this implies that the C is 0, right? So that clearly gives us that the voltage function is this, right? That's 20 sine 500 T, right? Volts. Right. And now we are trying to find the voltage when our time, when the time is 10, right? So this gives us 20 sine 500 times 10, right? So that's 20. And remember, very important, because we are dealing with trig here, you make sure that you are doing the computations in radians, right? Sorry. So that's 20 sine. So we have 500 times 10 punched right. Yeah. So this is what we have, 20 sine 500 times 10. So this gives us the voltage we are looking for. So that's minus 19.75 for dp, 93 volts. All right, so that's it.